So we've been talking about multi-cloud for years and years in the industry now. Everyone wants it. There's a company, Flexera, that used to be RightScale. They've been doing the study for years now as well. What are the top deployment architectures that every enterprise goes after? And without question, every year, it's always multi-cloud. So again, we see 87% with the vast majority of that being hybrid cloud. The problem, though, is that even though this is what every single enterprise wants, and frankly, this is what the industry wants from a vendor perspective, we're not there yet, and we have a long ways to go. Now, if we want to really start to address these things, I think there's a few key problems that we need to address. First off, when we think about multi-cloud and how do we start to build out these federated architectures, we have to understand that we have to address data, not just cloud. And this is something that we've been talking about here in Europe and within the Eclipse Foundation for quite a while. But I just took up the IDSA's charts around enabling the digital economy. Because what do we do with multi-cloud is really to enable these workloads to process our data and to be able to do things. The second thing that we have to do, in addition to dealing with data, is that we have to start to build out the architectures in terms of how do we actually run workloads across different clouds and integrate these together. But there's a lot of technical challenges in terms of how this becomes possible. So first off, there's a challenge in terms of cloud services are not compatible from one cloud to another. If I start to use one particular cloud, the vast majority of the services in a given cloud, especially the very large ones, are all proprietary and bespoke to that one particular cloud. This leads to an architecture that I have to create different silos in terms of how do I start to architect my applications, because it forces me to say I use this cloud for this particular class of workloads because the capabilities only live in this cloud, or I go to that cloud for another class of workloads, or I go to a least common denominator approach. I do very simple workloads across a multi-cloud. So on the top here, we can also see from the same Flexera study, what are the top two workloads that are actually being done from a multi-cloud standpoint. The first one is apps being siloed. So again, as I spoke about, I use this cloud for that set of workloads, this cloud for that set of workloads, but it's not really multi-cloud, it's just I have multi-vendors. The second workload that is the top workload for multi-cloud is just disaster recovery failover. Again, this is not just a multi-cloud, this is multi-data center. One data center goes down, I have the ability to take my software, run it on another data center somewhere else, but I'm not doing anything in terms of what people are really going after. And I'm certainly not dealing with anything in terms of how do I share my data across workloads? How do I deal with application architectures that can span from one cloud to another? So this is a big, big challenge. Everyone wants to go multi-cloud, but we've been talking about this for years, and we see that we're not there yet. So I want to explore a little bit today in terms of what can we do, especially as an open source community, to actually get us to where we all want to go from an industry standpoint. Now, there's a lot of different initiatives that we've been seeing across the world, both from a project standpoint as well from a regulatory standpoint, that are all trying to address this issue of how do we get real cloud interoperability. So, for example, we've got GaiaX, and they'll be up here speaking in a little bit. We've got things in Europe such as the Data Act, which are regulating how do we start to have interoperability, and you'll hear a little bit more about that from Enzo. But even in the US, we have the Sky project from UC Berkeley. But the thing that they all have in common is that they all focus on if we want to have true multi-cloud interoperability, we have to have data interoperability, and we have to have cloud service interoperability. These two things go hand in hand, and so this is what I want to explore a little bit today. Now, we've been talking a lot about open source as a way to address this problem. I think we intuitively all here in this room understand that open source has to play a role if we want to have true multi-cloud interoperability. But there's a big gap in terms of how open source has been trying to deal with this so far, and that they're trying to build compatible stacks from one cloud to another. So whether you're dealing with Kubernetes, we're all here, around KubeCon, or if you're dealing at a lower layer, such as with OpenStack or other infrastructure projects, the idea is that if I only had two identical open source stacks in one cloud versus the other, then I would have perfect compatibility between the clouds, and so I can have multi-cloud. But that's not the case. There's two big problems with this thought line. The first is actually we don't see the same projects deployed identically from cloud to cloud. Even where we're using Kubernetes, the implementations of Kubernetes differs from one cloud environment to the other. So it's very difficult even to achieve very, very basic compatibility as we go from one environment to another, the way that these projects are being deployed. The second big challenge is that even if we ran identical software stacks and we gave you 100% compatibility between these two different offerings, we still haven't dealt with interoperability between the clouds. How do I make sure that my data can be shared from one cloud to another? How do I make sure that my cloud services that are available in one cloud are available in the other and can process the data as I bring it from one environment to another? How do I build architectures that actually span more than one cluster or more than one cloud? This is a horizontal architecture that has not been begun to address in the open source community today. Everything is focused on building vertical platforms and higher and bigger stacks. But no one is really taking a look from a broader open source community standpoint in terms of how do we start to deal with interoperability between different cloud layers. So I think that what we need to do is we need to start to build a cross-cloud horizontal interoperability approach using open source to say, if we really want to tackle this multi-cloud approach, how are we going to do this in terms of not just looking at building compatible stacks from one cloud to another, but actually how do we tackle the interoperability between one cloud and another. This will allow us to get the ecosystem we want. It'll help us to support a lot of the digital sovereignty, because if we have true multi-cloud, then we have true choice in terms of where do we run our workloads. And then we can also start to support a lot of industries, including here in Europe, for how do we build value across these ecosystems. So let's take a look a bit in terms of how we propose to start to bring this together. Starting from cloud services and an infrastructure standpoint, I like to use this analogy that if you remember when the iPhone first launched back in 2007, there was no app store yet. The only applications that you could get on your phone were the ones that were released by Apple. And everything else that ran on the iPhone was a web application running the Safari web browser. In fact, this is an advertisement from Apple back in 2007 where they show that for third-party applications, this is only available through web apps and multi-touch. And that's very much the same situation that we have in cloud today. Because when we think about cloud, I think there's two big problems that we have. One is what I call lockout, and one is what I call lock-in. From a lockout standpoint, now Quentin talked a little bit earlier using this Elastic example, and the fact that within the clouds, AWS is able to monetize Elastic search more than Elastic Cloud is able to produce in general. The reason you see symptoms like this in the industry is that only public cloud providers are able to create managed services in clouds. If you're a software vendor and you want to bring your solution into the cloud, you have two basic approaches you can take. The first, which is the most common, is I create a software image and I upload it into the image marketplace for a particular cloud. This could be an AMI, it could be a container image, it could be a virtual machine. The challenge, though, is that if an enterprise customer wants to use the software image in their cloud, they are responsible for how do they configure it, how do they operate it, how do they install it, how do they maintain it. When they go ahead and get a managed service from the provider, which provides the exact same software, they don't have to deal with any of those operational capabilities. The cloud provider does it for them. So it's a vastly superior experience to get the managed service versus the software equivalent in a cloud. So on the right-hand side, what we see is that a lot of software vendors then start to create a software as a service version of their software. So I've got a bunch of popular ones here, such as MongoDB Atlas or OpenShift.io or Confluent Cloud, et cetera. The challenge, though, is that even if I build a SaaS from my software, this is still largely inferior to the managed services that the cloud providers are able to give to you. Just as a simple example, if I took these 4 SaaS applications, they could be all running in the same physical data center, say in AWS. If I, as an enterprise, then want to start to build an application across these 4 SaaSes, I have to go to 4 different websites. I have to deal with 4 different identity systems, deal with 4 different billing systems, deal with 4 different network spaces, deal with 4 different data spaces, because they're all logically siloed from each other, even though they run in the same physical infrastructure, because each SaaS has no knowledge of another software application running in the data center, and they have no knowledge of the native services running in the cloud. On the other hand, if I just go to AWS or any cloud provider and I get the equivalent managed service, I don't have any of those limitations. Single sign-on, single billing, integrated data, integrated networking, and so on. So this is why it's a largely superior experience for the managed service providers to be able to give you managed services. And it's a big reason why we see that the software industry has a hard time going into clouds to be able to offer solutions because they're limited in terms of what kinds of solutions they can create in the cloud. So that's the lockout problem. The lock-in problem everyone is very familiar with, which, as I mentioned before, every enterprise wants to go multi-cloud. But the problem is that clouds have very, very few services in common. So for example, here I'm just showing the compute services that are available from AWS, from Huawei Cloud, and from Azure. And you can see just across these 3 clouds, we have 2 compute services in common. One is virtual machines, the other is Kubernetes. If I go into AWS and I use AWS Lambda, my application can only run in AWS because Lambda doesn't exist anywhere else. If I go to Huawei Cloud and I use Huawei FPGA Accelerated Cloud Server, I can only run in Huawei Cloud because that service only exists in Huawei Cloud. Or if I go to Azure and I use Azure Batch AI, same story. And this is because there's no such thing as service portability from one cloud to another. So what this means is that, as I showed in the earlier slide, there's 2 choices that enterprises make when they start to go multi-cloud and they want to avoid lock-in. One is they just silo. I use this cloud for that set of workloads, I use this cloud for that set of workloads, and I take full advantage of the cloud. The other one is I go least common denominator. I only use virtual machines and Kubernetes, and I forego the rest of the value that I get from the cloud in order to be able to have portability. But then we just see workloads like disaster recovery and not real multi-cloud architectures. So this is also a big problem from an industry standpoint. And we can't have a talk these days without talking about data and AI. But for me, this is sort of the ultimate example of lockout and lock-in because there is no shortage of software, data solutions and AI solutions in the marketplace. But if you want to run them as software solutions from a cloud, these are, again, very inefficient and very poor experience compared with the managed AI offerings, the managed data offerings that you get from the cloud providers. If you bring in a software storage solution or a software data warehouse, they cannot provide native data back for any of the native services in the cloud. They can provide you, support for other software you run on the cloud, but not for the native services in the cloud directly. So it's a big challenge compared to the native data solutions. Same thing from an AI standpoint. If you want to integrate your AI capabilities with the other cloud services you can only do that with the managed service equivalent, not coming in from a software layer. From a lock-in standpoint, a lot of people think if I could only export my data out of one cloud and bring it into another cloud, or if I could only set up a data space to share data from one cloud to another, I'm set. I have complete sovereignty over my data. But that's not the case because data is highly structured and coupled to a data processing service. So for example, if I could take all my data out of Azure OpenAI service, or if I could take all my data out of Amazon Redshift and export it to another local cloud here in Europe, it doesn't do me much good because there's no such thing as an OpenAI service at that cloud. There's no such thing as an Amazon Redshift service at that cloud. So I can bring my data over, but I can't process it. So you have to bring both the data processing as well as the data together if you want to achieve true solution to the lock-in challenge. So if I come back to my smartphone analogy, I mentioned when the iPhone first launched in 2007, there was no such thing as an app store yet. But of course, that's not the case today. Especially here, app stores have been making all sorts of news because of the DMA. We can see that there's a relatively open market for applications, and this has enabled you to say, if I want to switch the manufacturer of my phone, I can easily do that because I just download my application from the App Store, I take my data across the cloud, and I have portability from device to device. And so third-party applications today are largely functionally equivalent to first-party applications. And so there's a whole ecosystem of third-party applications that we have now in the mobile market that does not exist in the cloud market. There's no such thing as a third-party managed service. So what we've been working on in open source is an initiative that we call Open Services Cloud. The reason we call this Open Services Cloud is just as open source opens up access to the software inside of your software, and you get the source code. We want to open up the service layer inside of clouds and give you the ability to create services that are portable and open across a multi-cloud. As Gail mentioned earlier, we have this project at Eclipse Foundation called Expanse. It's a little hard to read in the sun here. But basically, what we're focused on is solving that lockout and lock-in problem that I mentioned. So how do we do this? So first off, let's take a look at the lockout issue. Within every single cloud provider, there's a set of operational capabilities that turn software into a managed service. These are things like, how do I do billing, how do I do identity, how do I do deployment, how do I do console access, etc. Every cloud has them, every cloud keeps them private for themselves. So the first thing that we are doing is we're assembling a set of companies that want to work with us here in the ecosystem to say, let us open up access to this layer so that for the first time, a third-party software company can come and create a native managed service in our clouds. This would be the equivalent of creating an app store for clouds, except we're creating a cloud service capability for anyone to be able to install a managed service in the clouds. So solving the lockout problem, giving everyone this open access. The second thing that we want to do is we want to solve the lock-in problem. So we've open sourced how do we implement this actually. As I mentioned before, in order to operationalize, how do I turn software into a managed service, we have to expose those capabilities such as identity or billing or console or deployment and metering and so on. So we're defining in open source, if a cloud provider wants to let you create an operational managed service in the clouds, they must expose these APIs that we've implemented open source. The second thing that we've done is we've created the ability for you to describe what is the service that you want to implement, and then to bind that service through plugins to different cloud providers. So because we've done this, if you're a software provider, you can integrate once against this Expanse framework, but now you're a portable managed service across a multi-cloud. So we've introduced service portability for the first time into the industry, and we can solve the lock-in problem. Once we do this, we think we can start to really open up the opportunity for a lot of the smaller players in the ecosystem. Now, if you're a very, very small cloud provider, your biggest problem is you're chasing after the giant service catalogs of these hyperscalers, and you're never going to get there. You don't have enough money to invest to build out the catalog. But if we can work together in the open source ecosystem, as big as the catalogs are at any of these individual hyperscalers, I bet even Amazon plus Google plus Microsoft combined can't build as many services as the entire software industry if we enable every one of these to become a managed service across the cloud. Similarly, if you're a small software vendor across Europe, it's too expensive for you to go after every little cloud across Europe and do some custom integration with them. But if we had a standardized way to do that via open source, now it becomes possible because I just do my integration work once, but I can address a huge federated ecosystem of different cloud providers. So Open Services Cloud, we think is really the fundamental layer for how do we start to introduce a real multi-cloud interoperability. We have to introduce service interoperability and portable services from cloud to cloud. But as I mentioned before, that's not enough because you have to have both cloud services and you have to have data that comes together. So I've sort of drawn this high-level stack in terms of what are the conceptual layers that you need to achieve interoperability from cloud to cloud. So we need to have what I'm calling here service spaces, the basic cloud interoperability. On top of that, we need some fundamental services that start to deal with how do I establish trust and interaction between different clouds from a service standpoint. We have to deal with how do we share data between different clouds. So we have data interoperability. So when I bring my service from one cloud to another, I can also transfer my data in a trustworthy way. And then we want to build a variety of different solutions that actually take advantage of this. And the great thing is that actually here at Eclipse Foundation, as Gail mentioned in his talk, we already have a lot of these efforts going on. So we have the Expanse project I've been talking about, but we also have projects from Gaia X, from IDSA, from Contenna X, and so on, all operating at these different layers of how do we deal with interoperability from different clouds. The challenge that we have is that all these projects are sort of functioning in their own isolated ecosystems, and we haven't really brought them together in a really large coordinated effort at the Eclipse Foundation. So what would be really great is that if we could start to work together as an ecosystem, all the different companies and all the different projects that are working across all these different solutions, if we really want to tackle this solution as an industry, we need to start to take advantage of the fact that we're all here at Eclipse Foundation and take advantage of their structures, such as working groups and interest groups, to say, how do we cooperate together in order to come together to start to build out this true cloud interoperability solution. So I think that's the big opportunity that we have here working together, is that we can start to take a look at all these different pieces that we'll be talking about during our time here today. But how do we start to build a real multi-cloud interoperability that supports a lot of the industry needs, that supports a lot of the digital sovereignty needs that people have, that can start to deal with regulatory requirements that require interoperability and secure data sharing between clouds, and that also start to fill an unmet need from an industry standpoint. One thing, it's a little washed out on the slide here, but we had worked with Decision last year. They did a very nice study to analyze what would be the impact of using Open Services Cloud and this open source approach into the European cloud market ecosystem. You can get a copy here. But for me, the most exciting takeaway was they did a whole bunch of number crunching, and you can see it in the report. But basically, if you take a look at the current growth rate in the European cloud market, it's about 15%. This can accelerate that to 279%. So a massive, massive growth in the market opportunity in the cloud industry in Europe by all coming together and working in this open source approach. So how do we get there? So I sort of laid out a lot of the piece parts that are happening here at Eclipse Foundation. I think there's a lot of interest to see this happen in the industry. I think there's at least two approaches that we can take, and very happy in the discussion time to see if there are other ideas. But basically, we've got one working group that's already established around data spaces at Eclipse, and we've got a bunch of other projects that are not necessarily into that, and that go beyond just data spaces, because we had to deal with service interoperability as well as data interoperability. One approach is we expand the scope of the data space group, and we start to work together there, and then we bring together all these other different projects. Another way, we could just start a parallel group, and then the two groups coordinate in the beginning, and maybe we merge together after some time. But this way, at least, we can start to bring some structure in terms of how do we coordinate across the projects. For me, the most important thing is just that we can all get to an end state where we're all working together to address a lot of these challenges across the industry. But we should figure out how do we get there in a very open source and community way, which is that we all show up, we join the community, we code, and we vote, and we say this is the way we want to push it. And that's the great thing about working with Eclipse Foundation, is that they can provide us with this kind of structure. So that's it for my talk. Thank you very much.